Hi guys, we're on page 45 in your notes packet for today, and we are talking about evaluating logs. So we know that a log is sort of like another way to represent an exponential function. So we're going to take a look at how to evaluate those. We're going to start with problems that we're going to evaluate on our calculator. So on your TI Inspire, let me pull mine up here. I'm on a calculator page. If I want to evaluate a log, we actually have a key for that. So if you look here at the 1, right next to it, I have that 10 to the x key. And then in blue, right above, I can see it says log. So if I hit the blue control button and then that key, I get a log that pops up on my calculator. And on the TI Inspire, you get a box where you can type the base of your log and then where you can type what's called the argument of your log. So for number 1 here, where I do not see a base on my log, that means that the base is 10. That's our common log. So on my calculator, pull my calculator back up here. On my calculator, I'm going to type 10 in for my base, and then I'm going to arrow over so that I can type in my argument, which is 7 for this first example. And then I'll hit enter, and that gives me that approximation for my log. So the log of 7, or log base 10 of 7, is 0.845. We'll round to 3 decimal places there. For the next example that we see on our notes, we want the natural log of 0.25. Remember, the natural log is a log with a base of e. But on our calculator, if I don't want to type log base e, I could also just use the natural log key. So if I go to that 1 key and then over here is my e to the x key, and you can see in blue right above it is the natural log. I'm going to hit that blue control button so that I can get my natural log. And then we want the natural log of 0.25. And we get negative 1.386. For our last example on our notes, we want the log base 3 of 128. So I'm going to hit that blue control key. I'm going to hit that log button. The base for my log is 3, and then the argument is 128, and I get 4.417 if we round to 3 decimal places. So if I'm evaluating on my calculator, I'm going to need to use the blue control button and then either log or natural log. Now, we don't need our calculator to evaluate every log. For the first couple of problems that we looked at, if I were to rewrite this, this would be 10 to what power gives me 7. So that's not going to be a nice number because 7 is not a power of 10. Same thing with natural log. That means e to what power gives me 0.25. Well, that's not going to be a nice number. And then here, 3 to what power gives me 128. Again, that's not going to be a nice number. It's not going to be an integer or a rational number, which is why we had decimals that we rounded. For a lot of the work that we're going to do, we are actually going to be able to evaluate these on our own without having to use a calculator. So that's what we're going to look at here. So remember, as we go through each of these, I'm going to write out what am I asking in sort of that exponential format. We've worked with exponential problems. We've worked with exponents for longer than we've worked with logs. So I think for a lot of us, it's a little bit easier to think of the problems that way. So that's how I'm going to start each of these. So for number 4, log base 3 of 81 equals something. What I'm saying here is 3 to what power gives me 81. So 3 to what power gives me 81. This would be 3 to the 4th power. So that means the log base 3 of 81 is 4, right? Since 3 times 3 times 3 times 3 equals 81, that means 3 to the 4th power is 81. For number 5, this would be 1/2 to what power gives me 8. Looking at number 5, I can see I'm starting with a fraction, and then I'm ending up with a whole number. So that means I'm going to have to flip this. In order to flip this, that means that this is going to have to be negative. My exponent will have to be negative. So that means this is going to equal negative something. And so once I flip it, the 2 would be on top. And then 2 to what power gives me 8? Well, 2 to the third power. So my exponent here would have to be -3. For number 6, 9 to what power gives me 3? Here I've gone from a big number, 9, to a small number. So that means I took some kind of root, right? 9 is some kind of root. That means I'm going to need a fractional exponent. So, or I should say 3 is some kind of root of 9. Since 3 is the square root of 9, that means I would want the 1/2 power of 9. Anytime I go from a big number to a small number, that means I'm going to need a fractional exponent because I'm looking at taking some kind of root. Number 7, we've got the natural log of e to the 8th. So remember, natural log means the base here is e. So I'm saying e to what power would equal e to the 8th? The only thing I can fill in this box and have these sides be equal would be 8. So the natural log of e to the 8th is just 8. We're going to use this idea here of exponents being equal in one of our future lessons when we talk about strategies to solve exponential equations. Number 8, 32 to what power equals 2? Again, I'm going from a big number to a small number here. That means I'm going to want a fraction. So I'm going to want 1 over something. So essentially what I'm saying is what root of 32 gives me 2? This might be an easier problem to think of sort of the opposite way. 2 to what power would give me 32? 2 to the 5th power would give me 32. That means I would want 32 to the 1/5 power to get back to 2. So the log base 32 of 2 would be 1/5, right? Those fractional powers, remember, I could rewrite as a root. So what I'm saying here is the 5th root of 32 gives me 2. For number 9, 2 to what power gives me 1 over 8? 2 to what power gives me 1 over 8? I'm starting with a whole number and I'm ending with a fraction. So for number 5, we started with a fraction and ended with a whole number. We said that means we need to flip this. So we needed our exponent to be negative. Same idea here. If I'm starting with a whole number and I'm ending with a fraction, 1 over something, that means I need to flip this. So I need a negative exponent. The negative will flip this to 1 over 2 to the something. And then I need this to be 2 cubed so that I can get 8. So my exponent here had to be -3. So log base 2 of 1/8 gives me -3. For number 10, 4 to what power gives me 1/2? Now I'm going from a whole number to a fraction. So that means that I need a negative exponent, right? Because I'll need to flip this. And then 4 is bigger than 2. So once I flip this, it would be 4 to some power gives me 2. But 4 is bigger than 2. So again, I'm going to need a fractional exponent because I need to take some root of 4 to get down to 2. It's actually the square root of 4 that would give me 2. So I want the 1/2 power here, which means that log base 4 of 1/2 would be -1/2. Kind of a double whammy with that one. Number 11, 5 to what power gives me 25? Well, 5 to the second power, 5 squared gives me 25. So log base 5 of 25 equals 2. And then for number 12, I don't see the base here. That means that it's 10. So 10 to what power is 100? This would be 10 to the second power. So log of 100 is 2. A couple things to note here, and we talked about this as we went through. Anytime I'm starting with a big number and going to a small number, you need a fraction for your exponent. And then anytime that I'm going from a whole number to a fraction, or vice versa, from a fraction to a whole number, like we did in number 5, my exponent will have to be negative. Okay? So just some things to keep in mind. A couple other special properties we see for logs. If I have a log base b of 1, it will have to equal 0. Okay? What we're saying here is that b to some power equals 1. Okay? The only exponent I could take for a number and end up with 1, no matter what the number is, would be 0. Anything to the 0 power is 1. So if my argument for a log is 1, this would be, for example, 19 to some power equals 1. If my argument is 1, if it's going to equal 1, that means my exponent had to be 0. So that log will equal 0. If my base and my argument match, that means that log will have to equal 1. So what I'm saying here is b to what power equals b. So 4 to what equals 4, or 5 to the what power equals 5. 27 to the what power equals 27. Well, if this is just going to be the same number, that means I took it to the first power. So here, our base would be 10. 10 to what power equals 10? That would have to be 10 to the first. So that log equals 1. And then the last special property that we're going to look at for logs is when our argument is negative. Okay, so this would be b to some power equals a negative number. So b, whatever it is, b is positive, right? It says for all positive values of b. So 2 to some power equals negative 8. Let's use that for an example. 2 to some power equals negative 8. Well, I know that 2 cubed would give me 8, but it would give me positive 8. If I took 2 to the negative third power, that would give me 1 over 8. There's no power of 2. There's no number of times I can multiply 2 by itself that I'm going to end up with a negative number. Okay? I'm saying some positive number multiplied by itself a bunch of times would give me a negative number. That's not how that works. Positive numbers multiplied by positive numbers are always going to give me positive numbers. And when we talk about exponents, that means that it's got to be the same number. So that means that if I try to take something to an exponent and get a negative number, right, some positive base to an exponent and get a negative number, that's not possible. So we say that this is undefined. So when I'm evaluating logs, you can rewrite it in that exponential format to figure out what your exponent will be. Remember, if you're swapping between a fraction and a whole number, that your exponent is going to be negative. So your log will have a negative answer. And if you're going from a big number to a small number, that you're looking at a fraction here, and then those special properties that we talked about down at the bottom.